So in the last video, I showed you how this normal distribution function can help you to draw a bell curve for any non-standard normal distribution situation where the mean is not 0 or the standard deviation is not 1 or both, which is normally the case. So let's just say that we're looking at a population where the IQ norm, the mean of the IQ is not 100 but 105, and the standard deviation is 20. Much like I did today in class. So now it will draw the bell curve that relates and draw, if I go back to the home screen, I can draw the average value as a vertical line right down the middle by pasting the vertical line command and 105, and it will graph x equals 105, which is right down the middle. So we saw how to find the area between two boundaries, or to the left or right of a boundary, to interpret it as a probability. But this time, how would we find a cutoff for, let's say, the middle 90% of the data, or maybe somewhere at the 90th percentile? So if it was at the 90th percentile, we'd want to find a border where everything to the left of this is 90%. So there's a really cool feature that I showed in class today. If you push second vars and you do inverse norm, option 3, and what the syntax here is that you have to put the area that you want to the left of the curve, which is, if you want it to the left, which is 0.90 for the 90th percentile, and the mean comes next, which is 105, and the standard deviation is 20. And if you don't put anything after that, it will automatically do it to the, as it's the area is to the left of the boundary. So that means that somewhere around an IQ of 130 or 130.6, if such an IQ existed, because usually integer values, that would be at the 90th percentile. So if we go back to our graph, and I know that that value, that answer right there that I just got, is stored into answer, when I go back to the calculus feature and I do a lower limit, which is 4 standard deviations less than the mean. The standard deviation was 20, and 4 20s is 80, and 80 subtracted from 105 is 25, and the window settings start at 25. So when I perform an integral using the definite integral tool, I can only start at the very left side of the screen. Again, 4 standard deviations, 4 20s less than 105 is 25. So my lower limit is 25 on the very left side of this curve, and I'm going to go up to the answer that we just found for the 80th, for the 90th percentile, and it's going to fill that area in, and we know that it's going from 25 up to the IQ of 130.6, and this area in here represents the 90th percentile. That's a very cool way to use the graphing calculator to do an inverse norm probability, where you know the associated area and you find the cutoff score based on the mean and standard deviation for a non-standard distribution. If we were to try the same problem in Excel, it would be, we would need to use something similar to the inverse norm function, which is called norm inverse. So if I push an equal sign here and start typing NOR for the normal distribution, you'll notice that the second line item is normal inverse, and it automatically tells you the syntax and what comes next. So if you want and for Excel, it's always area to the left of a boundary. So if you want to find the 90th percentile, again, using Microsoft Excel, you put the area, which is associated with a probability of 90%, will be to the area of the boundary. Then you put the mean, which is 105, and the standard deviation is 20. And when I push enter, it finds that same value of 130.63, which is the IQ that cuts off the bottom 90% of the population and the top 10%. So only 10% of the population has an IQ greater than this. Let's say the next integer value above this is 131. StatCrunch is really cool. StatCrunch enables you to also do a boundary value for the top and bottom percentiles by changing this to standard if it's in between, and then you mark the mean here and the standard deviation, and instead of putting the boundary value here, Now, again, we're going to want the area to the left, so I can put less than or equal to here. I'm going to not use this value. I'm going to leave that value blank, but now put the decimal form of 90%, which is 0.90, and it will cut off and compute that cutoff score of the 130.6, which is the IQ associated with the 90th percentile. If you click on this bar again, as I showed in class, it shows these tick marks labeled in a scale that's incremental to the mean in the middle and going up by denominations of the standard deviation and down to associate them with the associated z-scores. Let's say that we wanted to find the middle 90%. So now I would click the between option, and I'm still going to keep 105 and 20 as the standard deviation, but I'm going to clear out these values so that they'll be found, and I'll put the percentage that's associated between the two boundary values, so that now when I compute this, it will find everything from an IQ of 72.1 up to an IQ of 137.8. That's the middle 90%. So the remaining 10% is cut up in this right tail and this left tail. And so the closest integer value to this would be 72, and the closest integer value to this would be 138. So approximately 90% of the population have IQs between 72 and 138. Pretty cool, huh?